All right, hey, Honors Chemistry. Here is a description of how you're going to be working with worksheet number 3. A couple of changes here. Instead of it saying then multiply by the appropriate factor, I would say identify which equation and use it. Which equation and use it. So you're going to tell me if you got to use P1 V1 equals P2 V2, V1 over T1 equals V2 over T2, P1 over T1 equals P2 over T2, and so on and so forth. And then, or the combined gas law, you could use P1 V1 over T1 equals P2 V2 over T2. Okay, so let's look at the first question, and then you'll be asked to draw particle diagrams of the initial and final conditions. So let's look at the first one. Let's see what it's asking, which equation I need, what can I ignore. So what would be the new pressure? So I'm looking for a new pressure. If 250 centimeters cubed of gas, what's centimeters cubed? That's a volume. 250 centimeters cubed of gas at standard pressure. Standard pressure is 1 atmosphere. Initially at 1 atmosphere. Is compressed to a volume of 150 centimeters cubed. N and T are constant. Cancel that out. So the only two factors I'm looking at are pressure and volume. So if I'm looking at pressure and volume, P and V, I need P1 V1 equals P2 V2. They are inversely proportional. That means if I increase pressure, I decrease volume. If I decrease pressure, I increase volume, and vice versa. And so let's look at this. Volume decreased. So what should happen to my pressure? The effect should be an increase in pressure. So now let's plug and chug into this equation. P1 V1, P2 V2. Let's write it down. P1 is 1 atmosphere. V1 is 250 centimeters cubed. V2 is 150 centimeters cubed. P2 is what I'm solving for. P1 V1 equals P2 V2. P1 is 1 atmosphere. V1 is 250. P2, I don't know. V2 is 150 centimeters cubed. Mathematically, if I want to solve this, I just want to divide both. I have to multiply these two together. I'll get 250 because 1 times 250 is 250 equals P2 times 150. If I want to solve for P2, I have to divide both sides by 150. 250 divided by 150 equals 1.67 or 1.7 atmospheres. That is the correct answer. And now, did we predict? Or was our prediction correct? Yep. Prediction was correct. Increase in pressure, my pressure increased. And so now what I want you to draw, I wrote a lot of work here. I'd like you to draw an initial and a final. I have a larger volume and then I have a smaller volume and I have the same number of particles with some arrows in there. I could draw the same thing here, same number of particles, but now the arrows are much closer together. Now, that kind of got a little bit messed up there because it's very small, but I'd like you to draw particle diagrams of initial and final. You're going to work on this worksheet very similar to how I did question number 1. You're going to fill in the table, tell me what happens to the effects, and then figure out which equation I'm going to use and plug and chug. You were going to do questions 1, 2, 3, 4. You're going to skip 5 and 6. You could jump to 7, skip 8, and then do questions 9 and 9 again, or this one's 10. To help set you up on the next one, it says the pressure in a bicycle tire is 105 psi at 25 degrees Celsius, which is 298 Kelvin. You take the bicycle up to Huntington where the temperature is -5. -5 plus 273 is 268 Kelvin. What is the pressure in the tire? This is pressure and temperature. That's directly proportional. So I'm going to use P1 over T1 equals P2 over T2. And volume and number of particles are constant. So if I want to draw a before and after, or initial and final, I'll probably draw them same particles, but one of these has a higher temperature. And how would I show pressure? Right, P2 is probably going to have a lower temperature, so it's probably not going to be bouncing off the walls as much as initially. Okay, so now you can finish the rest of question 2 and do the rest for this worksheet. Let me know if you need any help, leave any comments, leave questions, message me in the remind.